Okay, yesterday you learned how vectors have both magnitude and direction. So today we're going to add some more about the magnitude to it. So first off, whenever you hear magnitude with vectors, that's referring to the length of the vector. And then as far as notation goes, magnitude is represented by these two vertical lines. Essentially, it looks like an absolute value when we're talking about vectors. So right here in this problem, it is given to us that the magnitude of A is 8. So that means the length of A is 8, and then the length of B, the magnitude of B, is 11. So in this case, we want to find, what this is telling us, is we want to find the magnitude of A plus B. So here's where we learned what we did yesterday. First, we need to draw A plus B. So it's really already drawn for us over here. I'll show you again. It means we have A, you draw vector A first. At the end of vector A, you draw a vector B. And then we are given that there's a 72-degree angle between them. So now the vector A plus B is the vector that connects the end of, or the beginning of A to the end of B. So this green vector here is our A plus B vector. So if we want to find that length, we need to use the triangle we just drew. So up here in the givens, we have the length of A is 8. So that means the length of that first vector is 8. The length of B is 11. Obviously, my picture is not drawn to scale. That's fine. We need to find the length of that other side. So here's where we need to think back in time to the law of sines and law of cosines. Notice we have a side, the angle in between, and another side. So if you think back, that is a law of cosines problem. So I have to do some review with that. And remember to solve that. The side you're solving for is always the opposite side, so I'm just going to make it c squared. You can write a plus b squared either way. And then the formula goes 8 squared plus 11 squared minus 2, 8, 11, cosine 72. And then you just type that entire thing in your calculator and take a square root. So once we type the right side in, we get 130.61, and that's c squared. So then take a square root to finish solving. And we get that the magnitude of A plus B is equal to 11.43. And that's it. So for these are essentially just law of cosines problems. You just have to be able to draw the picture first. So now the second one, same two vectors, but this is an example of when the picture has to be manipulated before we can use our law of cosines. So this time we want the vector A minus B. So remember to draw that out. First we'll start with A. A is the same as it looks over here. Goes up. There's our vector A, which we know equals 8. So now for B, if our normal vector B goes kind of to that left up, we're subtracting now, so a negative B is going to go the exact opposite direction. So instead of going to the left, we're going to draw our line down, and that would be negative B. Now the length of that, length can't be negative, so it's still 11. So the other piece we have to figure out is that angle. We know when we had a positive B that the angle was 72 degrees. Well, negative B is just going to be on a straight line. So keep in mind, your straight lines are supplementary, meaning they add up to 180 degrees. So to find that angle in there, we need to do 180 minus 72. And that'll give us our new angle in between. Because now our end goal, that A minus B vector, is going to connect to the beginning of A to the end of negative B. And there's A minus B. So again, side angle side, law of cosines. So we just need to remember that formula. The magnitude of A minus B is going to equal 8 squared plus 11 squared minus 2, 8, 11, cosine 108 this time. So if we type all that in a calculator, we get, oops, we're squared over there, that A minus B squared is 239.39. Finish solving by taking a square root. And you should get that the magnitude of A minus B is 15.47. So same idea as the last one, you just have to do a little bit of extra thinking in that drawing step.